Hello everyone, I'm Kenzie. In today's video, I'm going to talk about chemistry of carbohydrates. Before starting the video, I would like to thank Miss Mariana for allowing me to use her YouTube platform. And don't forget to like, comment, and subscribe for more chemistry-related content in the future. Food. In a daily basis, all of us love to eat food, regardless of it being breakfast, lunch, or dinner. Even though the dishes are different, we Indonesians have something in common. We always add rice to our food. Why do our body crave rice so much? Because our body needs the carbohydrate contained in rice. Carbohydrates are the perfect nutrient to meet your body's nutritional needs. They nourish your brain and nervous system, provide energy to all of your cells, and help keep your body fit and lean. Carbohydrates complexity are divided into two: simple carbohydrates such as monosaccharides, and complex carbohydrates such as disaccharides, oligosaccharides, and polysaccharide. Monosaccharide. A monosaccharide is a monomer of carbohydrate. A monomer is a small molecule subunit that can be combined with a similar subunit to form larger molecules. Monosaccharides contain one sugar unit such as glucose, galactose, fructose, and etc. We can name the monosaccharides based on the number of carbon atoms. For example, triose. It has 3 carbon atoms, 5 carbon atoms in pentose, and 6 carbon atoms in hexose. Glucose, the most common monosaccharide, is an aldohexose. It is a sugar having 6 carbons in a straight unbranched chain, which ends in an aldehyde group. The atoms in glucose can be differently arranged, thus creating isomers of glucose. Here are some examples of glucose isomers. Glucose is a common source of energy for living things. It is easily broken down by most cells in a process called glycolysis. Many cells break it down further during aerobic respiration. Glucose monomer can be put together to make starch and glycogen. Plants store energy as starch, while animals store it as glycogen. Structural carbohydrates such as cellulose in plant cell walls and chitin in the exoskeleton of insects are also made of glucose monomers. Polysaccharides. Polysaccharides contain many sugar units, more than 10, in a long polymer chain of many repeating units. A common polysaccharides are starch, glycogen, and cellulose. Oligosaccharide. Oligosaccharide is any carbohydrate from 3 to 10 units of monosaccharides. A large number of oligosaccharides have been prepared by partially breaking down more complex carbohydrates, such as polysaccharides. Disaccharides. A disaccharides contain 2 sugar units. In almost all cases, one of the sugar is glucose, while the other sugar being galactose, fructose, or another glucose. Common disaccharides are maltose, lactose, and sucrose. Fructose. Fructose is a simple sugar that gives fruits and vegetables their sweet taste. Sometimes a single glucose and a single fructose will combine to form sucrose, or common table sugar, which is a disaccharide, or a sugar composed of 2 monosaccharides. Carbohydrate overall structures. All carbohydrates consist of carbon, hydrogen, and oxygen atoms, and are aldehydes, and multiple OH groups, or are compounds that can be broken down to form such compounds. The reaction mechanism. The type of bond formed between glucose monomer is glycosidic bond, or glycosidic linkage. It is the type of covalent bond that joins a carbohydrate sugar molecule to another group, which may or may not be another carbohydrate. This is the diagram of the reaction mechanism. So basically, monosaccharide 1 releases hydrogen atom from oxygen, and monosaccharide 2 releases hydroxide atom from the carbon chain. Then oxygen from monosaccharide 1 will make glycosidic bond with the carbon from monosaccharide 2. Thus, it will create a larger chain and water. This reaction occurs by condensation polymerization. Addition polymerization will not occur or cannot occur because addition polymerization only applies for alkene. Carbohydrate as polymer. Amylopectin is a polymer of several D-glucose molecules. 80% of amylopectin is present in starch. As we can see here in the diagram, amylopectin molecules are linked by alpha-1,4 glycosidic bonds and alpha-1,6 glycosidic bonds. Application in everyday life. Carbohydrate polymers have current or potential application in areas such as bioenergy, bioplastics, biomaterials, and biorefining. Why carbohydrate polymers are better? Carbohydrate polymers are an environmentally friendly answer to synthetic polymers. It is also found in abundance and are renewable. It can be easily modified to make materials with superior properties. And also it has a long cost. For this reason, there has been a lot of interest in recent years around using carbohydrate polymers in various commercial applications. Carbohydrate polymers have been touted as a class of molecules that can prevent metals from corroding by acting as a chemical inhibitor. Chemical inhibitor can be used to protect metals against changes in pH, temperature, and moisture. Many carbohydrate polymers have unique inhibiting mechanism to counteract corrosion, where they have specific absorption center that can absorb various molecules that will cause the metal to corrode. The inhibiting center is due to the cyclic rings in the long chain being able to form bonds with the incoming molecules, thus trapping the corrosion-inducing molecules. We've reached the end of the video. I hope you learned something new from it. Don't forget to check out the other videos if you want to learn more about chemistry. Goodbye.